Okay, everybody. So I understand that when you're doing polynomials, functions, and in behaviors, especially in AP pre-cal, things become a little harder to understand when you're doing this. And what I want to do is kind of show you a little bit about what's going on here, because I understand this could be a little bit hardening to understand, and it really is not. You just have to you just have to kind of see it. But we're going to do this with also limit notation too. So let's go ahead and start with maybe a thing like this. So we have a polynomial g of x. This is 4x to the 7th power. So this is a 7 minus 3x to the 4th plus x. Now, there's a number of things you could do here, but what they're asking you is that I want to know the in behavior. So uh, we could graph this, but what maybe we could do instead, why don't we kind of see what characteristics there are? So maybe we should do this. I know this has 7 to the 7th power, so this has a degree of 7. So I know that. Now, do I know what the graph looks like? Do I really care? I do care in a little way, but I want to see what's going on with the graph. So maybe I know that it's degree 7. By the way, that is positive. So the graph has to go like this. By the way, this has TP, which is turning points, and you're going to go in minus 1, which is this has 6 turning points, and this is positive. So we know that it's going to go like this and like this because we know that this graph is odd, and it kind of goes like this. But we got to be very careful, because if the turning point is 6, but this is odd, we need to kind of know if there's 6 turning points. So here's what I mean by the turning points. It's going to go up. It's going to go 1, 2, 3, 4, 5, and then 6. Now it could do this. So this is it could. We don't know a whole lot about this yet. We know it's going to be we know it's going to turn 6 times. The in behavior goes down and then it goes up because of this odd. Remember, this is odd, and it's positive because we know this graph too. This is our parent resembles this. So we understand it, but what are we looking for? We are looking for in behavior. So this is an in behavior, this is an in behavior. So let's demonstrate what they want there. We know the graph here, so we're going to start here. We're going to take a limit. Now, what a limit is that, to kind of describe this, let's say, you have a graph here and it looks like this, and it's kind of, this is what you're doing. Maybe here's a point. So this is a point. This could be any point, right? And what happens as you approach this way? So as you're going down the river, you are approaching the point. And you're approaching the point from the what? Are you going from the right or to the left? Well, this is the left. So you're approaching it from the left. If I go this way, you are approaching it from the right. Is that correct? Because here's the left, here's the right. You are approaching that. So what a limit does is it describes what's going on as I go from the center all the way out here on the x. So every x, so as x goes to negative infinity. So you're going to start here and you're going to kind of go this way on the x-axis. And as you go down on the x-axis of g of x, the limit as it goes further and further along on the negative x's, it's gonna follow this, because this is continuous. It goes down forever. We don't really care. We just want to make sure what it's doing. So as you pick one of these points, what is the output? As you pick one of these points, what's the output? Well, the output's going to be some number. But guess what you can do? You can keep going and pick any negative x you want. You're still going to get some value. So we are going to go to, what we're going to go to is negative infinity, because as you go this way, these points keep on going down forever to negative infinity. So that is how you would describe the end behavior of this side. Now, what happens when you go this way on the positive x? Well, this is going to be the limit as x goes to positive infinity. You can put a positive if you want. You don't have to. But you're going this way on the x-axis. Here's the x-axis. You're picking an x, and you're going to obviously get an output somewhere up on this graph. Okay, you're going to get an output. Now, we could go to billions, trillions. It doesn't matter. But what's happening as we are taking this function, as we are moving down this road, we are going to get an output on this graph. And that graph is positive infinity. So this is how you would describe this as an end behavior of just a regular polynomial. And right now, I don't care what goes on here. I care about the end behavior using this notation, because this notation describes what is going on as you go down the road. So that is one example of this. So let's say we have another example. So maybe we can get this one. So maybe we're kind of like this. We have an end behavior here. We go up like this or something like this, right? So this is our function. Now, we only want the end behavior of this. I care a little bit about what's going on with the graph, but not necessarily up here yet. Remember, there's a whole lot we're doing, but we're only focusing on one thing. So let's look at this here. So what happens is if I go this way? Well, if I go down the road on the negative x, I'm going to go the limit of x goes to negative infinity of whatever the function is, equals, well, what's going on as you're going down the negative x's? You're going to get a point down here somewhere. Where is it? I don't know. It's further along down the road. That's going to be negative infinity, because you keep going down that road, and it doesn't matter where you go, but you're telling the reader that you are approaching down that far. Well, what happens if you go this way? Well, if you go this way, you're also going to go to positive infinity. You're going to go positive infinity all the way out here. Infinity is way out here. As you're going down the x-axis, you're going to infinity. You're going to on the x. But what happens when you go down? Well, you're going down to, well, negative infinity. So that's kind of what's going on with this. Now, if you flip this up like this, you're going to change these to be positive. I hope that you're seeing that. So these are both positive. These are both negative. It's not a very hard thing to see. And that's just part of this. So there's a whole bunch of examples on this, and don't get all wild up on this. So let's look at some polynomials with complex zeros, because complex zeros, they might have a different thing, but let's first look at something different. Let's find the intervals of a condition. So you might come across something like this. This is x squared minus 5x plus 4. And then you're going to say, okay, when f of x is less than 0. So let's say you have a situation like this. The first thing we have to understand is that this is a polynomial. So what if we had a graph? Now, we're not going to make the graph the best in the world, but I know a little bit about this already because I had a lot of math. I know that this is x squared. Well, x squared might do something like that. It might do something like that, but we would have to, maybe find the vertex, negative b over 2a, and fill all that stuff in. But that will give you the vertex at a certain point. But remember, this thing is saying less than 0. So when you see this is less than, you're thinking, here's the x-axis, here's the positive x-axis, here's the bottom x-axis. I want to get this. This is what I want. This is what I want below the x-axis. I want below the x-axis. You might say, hey, what if this was positive? That would be above the x-axis. So don't let that throw you around, because that's kind of what's going on with this. That's all that's saying. So I want stuff that's below. I want things that are negative, in the negative territory, of the axes. So when you're doing this, have some sense about what's going on with this and that. Now, here comes the part that you need to see. I want to satisfy that condition. So to do that, you have to factor. You have to factor. And I'm hoping that you can factor that pretty carefully. You can use the quadratic formula or the diamond, or completing the square. You can also graph it if you have that choice. But let's say you don't have a graphing calculator. This is no graphing calculator one. So I got to factor this. So I'm just going to think, okay, I know that I have to do this minus 5x plus 4. Now, maybe this will be like that because I know a little bit. This is x, this is x. This has to be 4. This is minus 1. Let's check if this is right. Well, that's that. This is going to be 4, and these two will get me minus 5. So I already know how to factor that. That's nice. And then I'm going to make this equal to 0. Well, what you could do first, you could change it to that. You could change it to that, or you can wait to do that. I would just wait and just get the factors and then solve. So this is called the zero product property. And what this means is that you're taking a product and setting it equal to 0, and then you're going to factor or solve. So you're going to do something like this. Okay. And then this is going to be 4, and this is 1. Okay. These are a question mark. Why do you think I'm questioning these? Because I got to go back up to here. This is telling me I'm looking for values in between these to get these to be negative. So if that doesn't make sense, here's what you're going to do. To do this, you can make a little table. And you can put, here's the x and here's f of x, which is your y. Now, here's what I want you to understand. You're looking for values less than 0. But do you see how this is 0 and that is included? See how that minus, that has a little dash below it? That means you can include. I can't spell include. Include that. Sorry about the mistake there. You can include that. So that means I can come down here and say I have my solutions at 1 and 4. Okay, on the number line, where is 1? Well, 1 is right there on the number line. Where is 4? Well, 4 is right there. Okay, what I would like you to do is kind of put a little separation, because you know those two values are going to be your solutions. And those points are going to be 0 and 0, right? Because if you were to graph this, you would find out if I put 4 into my function, if I put that 4 into here, would that equal 0? And you would say yes. So that 4 and that 1 also makes a 0. But the question is, I'm looking for less than 0. Not just 0, less than 0. So I'm going to go over here, and now I'm going to kind of do this. So I got to pick some intervals that are in between here. So maybe I'm going to pick negative infinity to 1. Why am I picking negative infinity to 1? Because remember, I can pick any number in between here. Could I pick a number between here? You can pick what? Maybe I want to pick a 2, because that 2 is between 1 and 4. Well, what's bigger than 4? Well, 5. So now here's what you're going to do. You're going to take a number. Let's say 0 for here because 0 is between negative infinity to 1. The reason I'm picking 0 because it's not 1 and it's not 4. So what I'm going to do, everybody, is that I'm going to take that 0. I'm going to go up to here. And you're probably thinking, why am I going to use that factored form? You could use this form here. The only thing is you have to use this. You have to use squared, all that good stuff, and it has to equal to whatever number it is. I'm going to use the factored form because it's a lot easier to compute. So if I put 0 into here, that's 0. So if I put 0 into there, I have negative 4 times. If I put 0 in there, don't I get negative 1? So if I put 0 in between here and here into here and here and multiply them, I don't I get a positive 4? I don't care about the 4. I care about that sign right there because that tells me that information. So that is positive. Now, if you want to, you can go through all these numbers between negative infinity to 1. You will always get a positive answer. You can try it if you want. I'm not going to do it. I'm done with that because this is saying less than. So now I'm going to pick a number between 1 and 4. So I'm going to pick 2. So I'm going to go back up to here. I'm going to go back up to here, and I'm going to put it in for these two numbers. So let's see. 2 minus 4 is negative 2 times, if I put 2 in there, that's 2 minus 1. That's 1. And what? Oh, that is negative. I don't care what the number is. I know it's negative. So that is negative in between there. I'm going to pick something a little bit more than 5. Or I'm going to pick 5, but a little bit bigger than 4, right? So I'm going to take that number. I'm going to put it right in there somewhere. So that's going to be 5 minus 1. Well, 5 minus 1 is 1 times 5 minus 1. 5 minus 1 is 4. I don't care what the number is, but I know it's positive. So there we go. So now I'm going to look at this and I'm going to think, okay, I want stuff that's less than or equal to. Well, look at here. That is positive. That's gone. That's positive. That is gone. The only thing that works is between 1 and 4. Do you see that? The reason I'm picking 1 and 4 is because that's included. So you're going to kind of go back here and you're going to write this answer. You're going to say, okay, my function is less than 0 on the interval 1 to 4. 1 to 4. Now you're probably thinking, why are you putting 1 to 4? Remember, this is saying I can include 1 because at 1 it's 0. At 4 it's 0. But in between it's less than. So I'm hoping that that's making sense of that one. What I want to do is kind of maybe do one more. But this one requires us to do something different. I'm going to kind of go a little faster on this one because I think that you're kind of getting the hang of this if you think about it. So I'm going to pick this one, which is x squared plus 17x, maybe 70. And maybe I want to pick when g of x is greater than or equal to 0. So that's what I want. So I'm going to kind of do this kind of fast. So you're going to factor this a little bit, and that should be 7, that should be 10, and then you're going to set these equal. There you go, and there you go, right? So you got the factors. Now, you're looking for greater or equal to. Greater or equal to. So you're going to make a little number line. you're going to go x, g of x of your function, and you're going to put these in. But you might remember, you want to start a little bit down. So this is -10, and this is -7. Think of the number line here. Now, at -10, it has to be 0. At -7, it's 0, according to this right here. What is between negative infinity to -10? Well, pick a number here. Let's pick I don't know, -11, because that's between negative infinity to -10. What is between -10 and -7? Well, there's only a few numbers here, but we're gonna pick I don't know. Let's go ahead and pick maybe -8. Now, do we want to go on a little bit? Well, yeah, because it still does go on. What's here? Well, I want to pick 0, because remember, you're going to positive infinity here, because you have to go this way, because the graph is continuous. So now what? Well, this is where you have to plug -11, -8, 0 into your factored form. So you're going to take this and put it there. And by the way, if you do the math really carefully, you should have positive. I'm not going to show that to you, because all you have to do is just plug that into there, and it should be positive, by the way. You're going to plug -8 in there, -8 into there, and multiply them. I bet you anything you're going to get negative. Do I care about the number? No. If I plug 0 in, here it's pretty easy. 0, 0, 7 times 10 is 70. Well, obviously that's positive. I am looking for greater than or equal. Well, that's that one and that one. That verifies this, or that and that, because you want to include 0 because it's included. So here's what you're going to write. You're going to write g of x is on greater than or equal to 0 on the interval of negative infinity to -10. All right. Do you see how we have to jump? Do you see how we have to jump over here? Because we can't include this, we got to jump. So to do that, you're going to put, it looks like a U. Now, this U is for like a union. It's like a connection. It's like a connection. It connects this piece to this piece without doing this piece. So it's like that jump. It's just a connection. And then the connection is, well, -7 to, well, positive infinity. And that is what they would look, that's what they're looking for when you're doing this. There's a lot here, but don't overdo this, because there's still a lot here. The only thing that we need to cover is we need to cover complex zeros. Now, that has to do with a couple things. So real quick here, remember what complex zeros. So we have complex zeros. So what does complex zeros mean? Well, complex numbers, say that I had a graph that kind of did this. It goes here, it goes here. These are real. These are real. What happened here? Well, there's something here, but it's not touching here. And this is, let's see, 1, 2, 3. So this has turning points of 3. But remember, if you're given the graph, you go 3 plus 1, which is 4. So you're going to have x to the 4th, but negative. And the reason it's negative, because look at the end behavior. And it's even. So you have this kind of situation here. So there's something missing here. So I don't know if you remember. But if you have like x squared, right? You know what x squared is, right? It's a parabola that kind of goes like this. And technically, it should have 2 real numbers, 2 answers. If there's a 2 here, there should be 2 answers. What if there was a 3? There should be 3 answers. If there was 4, there should be 4 answers. But according to this one, we have 2, but we have a degree 4. So we're missing some. So where are they? Well, I don't know where they are. They are complex numbers. So here's what you're going to do. This could have 4, or let's say about 4 complex numbers. When I mean complex zeros, what I mean about 4, this degree is 4. They could be all. This could be have all complex numbers. But about, that means that there could be 4. In this case, there's 2 real numbers. So there's 2 real, but I need to go to 4. That means somewhere up here, there's 2 complex. There's 2 complex. And you could have a graph that looked like this. You could. Well, you're probably thinking, hey, I know that is the degree 4, but they don't cross the x-axis. That means they have 4 complex numbers. Do you see the difference there? So this one went down, I hit twice, but I have a degree 4. So there's 2 reals, and then the rest of them are complex. If I go the other way, without touching the x-axis, I have 4 complex numbers. I mean, you have to. And that's kind of the idea of complex zeros, or complex numbers, is that you have to hit the x-axis to get a real. But if you have a graph that has degree 4, there could be about 4 complex zeros. Or there could be 4 complex zeros. So it's really not that bad to kind of see this and visualize this. You just have to understand, well, go back to the algebra that you learned back with complex numbers. So I hope that this is really helpful, and let me know about this. And I will see you when I see you.